Hello and welcome to Biousage Lessons. Not only of nerves our coordination system is made of. We send nerves around to control different parts of the body. Of course, muscles are controlled by nerves, but we also use other kind of signals to send information around. And one main signal that is not nerves that's spread around are the hormones. Hormones are chemicals that are spread around our body, that are released by our body to signal to different parts of our body. They can be proteins, but they can also be lipids. They can be these different kind of structures. Like, for example, insulin is a protein, and testosterone and estrogen, they are lipidic hormones. So these kind of chemicals, they are producing glands, and these glands, they release these hormones, usually in the bloodstream, that carry it around to different targets. Okay, we are going to be calling this production as part of the endocrine system, because it's the glands that send stuff to the use of it inside of the body is called endocrine. Glands that produce chemicals that are released to the outside of the body, they are called exocrine, like sweat glands, of course, outside of the body, or like the stomach that releases hydrochloric acid and enzymes, they are exocrine because they release to the digestive tract that actually is kind of part of outside of our body, because it's in the digestive duct, that's an opening to the outside of the body. So endocrine system are the ones that are the hormones that are signaled around. Okay, nerves that we just saw, they are usually very directional. You have a nerve coming from one place, going to another place. They are usually very punctual, very directional. You have a nerve to move a certain muscle, another nerve to move another muscle, and so on. So usually nerves are more directional, punctual. They have one target. Okay, you have one signal that goes there to that one little target. Widespread signals, they are usually sent by hormones. Hormones are released, they go out through the body, and they may affect several different places at the same time. One example of that is adrenaline. Adrenaline is a hormone released by the adrenal gland. Adrenaline is also known as epinephrine. That's released by this adrenal gland in the top of the kidneys. That's why it's called epinephrine, because it's above the nephrons, the kidney. So the epinephrine, when it's released, it affects different parts of your body. It's going to be making your heart to speed up, your ventilation to also to get faster and to get deeper. It will dilate your pupils so you can see better if it's dark. It will break glycogen in your muscles to start get you ready to run, and several different other factors that are going to be happening all over your body because of one hormone. So hormones, they can be usually like that, although there are hormones as well that are kind of punctual. For example, the ADH, androgenetic hormone, they're released by your hypothalamus, and it controls the kidney. So it goes there on the kidney, and they do they make your body to regulate water because of that one hormone. So it can be a little bit punctual, but usually they are a little bit more widespread. Okay. Even when the hormone is directional, so like the ADH that's released and goes to the kidney, it's released through the blood, so it goes everywhere, but has one target. So it's a little bit more like a spread one. A few examples of hormones here. Insulin and glucagon, they are hormones that are going to be related to controlling glucose, the sugar in your blood. And we're going to have one lesson just for that. Okay? Thyroxine is a hormone that releases metabolism. It's produced by the thyroid gland. We're going to see that today. Leptin is a hormone that controls your appetite. We're going to see that today. Melatonin is the hormone that controls your circadian rhythm. We are going to see that one as well today. Okay. The sexual hormones like testosterone, estrogen, progesterone, LH, FSH, HCG, oxytocin, all those hormones are related to reproduction. we are going to see them in the reproduction class. Okay, so let's take a look. Oh yeah, of course, in adrenaline we just discussed. No, it's part of the option, but yeah, it's quite a simple one. Just to illustrate you here, we have a few hormones or structure related to hormones. For example, the hypothalamus over here is not actually, sorry, not hormones, I don't know what I have in my mind. Those are glands, okay? Hypothalamus actually controls the pituitary, which is a gland related to the hypothalamus. Very important one, and controls many stuff in your body by nerve and hormones. The hypothalamus has nerves that stimulate the pituitary to release hormones, but the hypothalamus as well also works with nerves. It's a crazy stuff, okay? The pineal that is related to melatonin is going to have to do with sensing light and controlling your circadian day. The thyroid gland that produces thyroxine, we're going to see that in a while. The thymus is for other stuff. The adrenal gland that's above the kidneys, as I just told you. You have the kidneys itself, they also have their own hormones over there. The pancreas, it's a very important organ. We saw that in digestion, that produces many digestive enzymes, but the pancreas also produces hormones like insulin, glucagon. So pancreas is a classic example of a mixed gland. It is endocrine because it produces hormones that are released in the bloodstream to go around the blood. But also produce other chemicals like enzymes that are released to go outside of the body. So they are exocrine glands as well. So in this case, they are endocrine and exocrine, so they are mixed glands, okay? Ovary also produce the eggs, but produce hormones. So it's also an endocrine gland. The testes also is an endocrine gland because it produces, apart from the sperm cells, also produce testosterone. So we have some examples of some glands here that produce hormones in our body. As I told you before, insulin and glucagon, we are going to have a class just for that, but just for you to know already, it is the one related to controlling blood glucose, okay, the sugar. Now, let's see this one, thyroxine. Thyroxine is a quite interesting gland. It produces a few hormones. The thyroid is a gland, produces a few hormones. The thyroxine is the star of the show. The thyroxine is also known as thyroid hormone and is the hormone that controls your metabolism. So if you release more thyroxine, you have a faster metabolism. If you produce less thyroxine, you have a slow metabolism. It's the one that's going to be regulating your metabolic rate. It's going to be quite important because in the end, your metabolic rate is going to be related to how active you are. Okay, this here is the formula for the thyroxine. If you are a chemistry geek, you're going to love this because in addition to all this organic stuff that you have over there, we have iodine. So this is the T4, the thyroxine, is a hormone that not only uses organic stuff, but it also requires an inorganic compound, iodine, as part of that. And because of this, we have to eat iodine in our diet. If we lack iodine in our diet, we are going to end up having problem. We are going to, a strong lack of iodine can develop a disease called goitre. The goitre is an iodine deficiency that the body ends up trying to compensate, producing because it produces a low quality thyroxine, it ends up producing more and more and more. So the thyroid gland ends up having to produce a lot, and because of that, it grows and gets very, very, very big, get enlarged. So it's not nice. And to avoid that, in most countries, we have a mandatory addition of salt with iodine. So the salt that you buy to put in your food, it contains iodine. So as soon as you eat salt, you're not going to have goitre because you're going to have iodine in your diet because it was added for us. If you buy by any chance salt that is not industrialized, that doesn't go to the process of industrialization, then you're going to be eating salt without iodine, then you will need to depend on other sources of iodine. And people that don't manage to get those other sources of iodine, then they end up developing goiter. Here you have an example of a normal thyroid gland. It's more or less the size around the trachea. And over here we have an enlarged thyroid gland because it's overproducing low quality thyroxine. So to avoid this kind of problem, having this enlarged thyroid gland, this goiter, it's good that we have iodine in our diets. Okay. Some people have a condition called hypothyroidism. Hypothyroidism is when the thyroid gland doesn't produce enough. So people with hypothyroidism, they end up having some well-known characteristics. Some of them you might have heard, others not. They are listed in here. But usually people with hypothyroidism, they have a lower metabolism, therefore they usually have intolerance to cold. They feel cold because they don't warm up their body so much. They might have a dual blank expression because the metabolism is kind of slow, they feel kind of tired, they have extreme fatigue. It may lead to anorexia. People don't want to be eating much. Bristle hair and nails, the hair and the nails start to be breaking down. They may lose hair, be apathic, lethargic. There are many problems with this hypothyroidism here. Usually hypothyroidism is not a very big problem because it can be treated with adding thyroid hormone to your body by taking just popping up pills. So if you have hypothyroidism, you probably have been to an endocrinologist that have prescribed to you thyroxine pills, and then you take it and then you regulate your metabolism with not a very big deal. The opposite of hypothyroidism is hyperthyroidism. And then in that case, people have a very high metabolism. So hypothyroidism, people with very high metabolism, that one is kind of tricky because you cannot take a pill to take out thyroxine from your body. So yeah, this is a little bit more difficult to control. One very common characteristic of people with hypothyroidism is intolerance to heat, because their metabolism is so fast, they're always warming up the body so much, they feel too hot all the time. Is it hot today here? And so, something like that. They may have bulging eyes, open eyes like that. Facial flushing, they become red. They can have an enlarged thyroid or not, depends on the type of hypothyroidism that's in there. You may have some heart issues like increased blood pressure, tachycardia, the heart beating a little bit fast and a little bit out of control. They of course have lots of weight loss, difficulty to gain muscle because they are always spending energy. And yeah, this kind of people here, it's kind of difficult because you cannot take it out so easily. I had an auntie that she's kind of a little bit hypothyroid, have a hypothyroidism, and it was interesting because at 2 o'clock in the morning she was cleaning the house because she was feeling awake and always active like that. So yeah, it's one characteristic. Again, it can be dealt with if you have hypothyroidism. You go to the endocrinologist, and the guys and girls, the doctors, are going to be treating you in there and trying to make your life better. Okay. Another hormone that we're going to be seeing here as an example of how the hormones work is leptin. Leptin is a quite interesting hormone, okay, because it's the hormone for appetite control. So basically, it's a hormone that's released by your adipocytes, the fat cells. They travel through your bloodstream to your hypothalamus, and the hypothalamus then signals to you, say, you had enough. It's a satiety gene. You eat, you start having a little bit too much, and your body signals to you say, yeah, you don't need to eat too much. It's the one that's going to be controlling. However, some people end up having some problems with this hormone. On the right here we have a normal rat, and on the left here we have its identical twin that had the leptin production blocked. So this guy here don't manage to control his appetite, and as a result, if food is available, it ends up gaining weight, which is quite interesting, because then people start thinking that maybe the regulation of leptin was the cause for obesity, and the research show that's not the cause for obesity in humans. It may have some influence. Some people may have a little bit more of difficulty on this, but not the cause for obesity. But then people thought, what if we put leptin in a pill and we just take them to inhibit our appetite, and then that could help people that have obesity to control the body fat and the ingestion of food. And it turned out that doesn't work. If you ingest leptin to control your appetite, it doesn't work. It's not efficient. So it was something that people wanted to do, but end up not working as well. But it's the one that we have going around. If you had a lot to eat, you probably have leptin being released from your adipocytes, going to your hypothalamus and telling your brain, hey, I think you had enough. You can skip this one, this extra hot dog now, because you already had enough. So just an example of another hormone for you. And finally, one more example of hormone for you, melatonin. This is quite interesting because this one actually we understand well, and it actually works if you take it as a pill. Melatonin, you may have heard, some people already take it in Brazil, although it's not very common to buy melatonin in Brazil, you have to buy it abroad. Melatonin is a hormone that controls the circadian rhythm. We have a circadian rhythm. Our body changes its metabolism, changes its functioning depending on if it's day or night, depends also if it's summer or winter. So it's the hormone that's going to be controlling this rhythm. What's interesting about melatonin is that it's the one that's going to be controlling your awakeness. If you are feeling sleepy or tired during the night and day, if you start skipping nights, and it's the one that's going to be starting getting regulated. But very interesting is the hormone that's going to make your life hell in jet lag. So when you travel across longitudes, we end up changing our time zone, and then it's time that your body feels it's time to go to bed, and it's morning. So you are going to be kind of totally irregulated because your pineal is going to be producing melatonin in the wrong times. It takes days for you to adjust for that. And one thing that can be done for you to regulate this, of course, it's take melatonin. If you take melatonin, you speed up this recovery. But because melatonin is produced by a gland there in your head that is sensitive to light, one thing that can help you a lot to regulate your circadian rhythm after you have been jet lagged is for you to go to the sun. Now, during the day, go to the sun, spend time in the sun, being affected to light. So during the day, you get lots of light, and your pineal is going to be sensing, okay, it's day, so let's start fixing this stuff, and let's start making the circadian rhythm to go back to normal. So that's one of the things that you can do if you don't want to pop up melatonin. But melatonin also works for fixing this. You can take it to fix your jet lag, and some people also take melatonin to help them to sleep. So especially people that by choice or by the job, by need, they have day and night rhythms that are a little bit off. The taking melatonin help them to set a pace and let them go to sleep with this interval. It helps to fix this this rhythm. So we took a look on some hormones over here. Take your time now to do a few questions in this quiz, and we will discuss about hormones in class. Bye bye.